today. So the thing is, today we see transformer. Transformer. So what is a transformer? It is a device. It is a device which is used which is used to increase or decrease to increase or decrease to increase or decrease the alternating voltage. The alternating voltage. It is used to increase or decrease the alternating voltage. The transformers are of the following types. There are two types of transformers. One is called step-up transformer. Step-up transformer. The second one is called step-down transformer. Step-down transformer. Up to here you can note. Written? Okay, we have another question here. What is a choke coil? Choke coil. What is a choke coil? A choke coil is an electrical device is an electrical device used for controlling for controlling current in the AC circuit. Current in the AC circuit. Current in the AC circuit without wasting without wasting electrical energy in the form of heat. In the form of heat. A choke coil is an electrical device used for controlling current in the AC circuit without wasting electrical energy. Okay, please note it. Can I clear?
Yes, sir.
Okay. There are two types of choke coils. There are two types of choke coils. To reduce the to reduce the to reduce the low frequency to reduce the low frequency alternating currents to reduce the low frequency alternating currents. Choke coils choke coils with laminated cores laminated soft iron cores soft iron cores soft iron cores are used. These are called these are called AF choke coils. AF choke coils. These are called AF choke coils. This is for low frequency alternating currents. That is one type. There is another type is there. It's very important to reduce the low frequency alternating currents. Choke coils with laminated soft iron cores are used. These are called AF choke coils. These are called AF choke coils. Next part. The next type is to reduce high frequency to reduce high frequency alternating currents to reduce high frequency alternating currents. Choke coils with choke coils with choke coils with air cores are used. Air core means are used. Nothing will be there in between. That is called an air core. These are called RF choke coils. These are called RF choke coils. Choke coils. So these are all the two types. Can I clear? Can I clear this? Hope I can clear. Next. Describe the construction and working of a transformer. Describe the construction and working of a transformer. So what is a transformer? How does it look like? It looks like this. So you can draw like this. Normally this diagram all of you would have seen. So it's like this. And now it goes like this. Okay. So this is connected to a AC source. AC source. This is called primary coil. Primary coil. And there will be something called secondary coil. Okay. Primary and secondary coil. I hope you know this terminology. So this is called secondary coil. So this is the input and this is the secondary coil. Secondary coil, which is the output. Secondary coil, which is the output. This is the input and output. Secondary coil. And this is the laminated core. Laminated core. This is the laminated core. Okay. This is the laminated core. Hope I am clear with this. What is lamination? Laminated core means what? Can anyone tell me what is lamination? What is a laminated core? Lamination means making some thin film. That's it. That is what it means. Making some thin film of the material. That is called lamination. Lamination means making something like a thin film. Thin film kind of thing. So the metal itself is made like a thin film or a thin sheet. That is called lamination. Clear? Hope you understood. That is to decrease the eddy currents. We'll read that. We'll read that. Why like that laminated core we will do. All these things we'll read today. Now, can I clear this?
Yes, sir.
Good. Now, what is the principle? Transformer. Transformer is based upon the principle of mutual induction. Mutual induction. It is based on the principle of mutual induction. This is the most important idea. Now, construction. Now, construction. What are the important things you have to know about construction? It consists of two coils, primary coil P, primary coil P, and secondary coil S, and secondary coil yes, and contains secondary coil yes, insulated from each other, insulated from each other, insulated from each other, wounded on soft iron core, wounded on soft iron core, is wounded on a soft iron core. Often the primary coil, often the primary coil is the input coil, is the input coil, and secondary coil, and secondary coil is the output coil, is the output coil, and the secondary coil is the output coil. Soft iron cores, okay, right up to here. So I'll clear the top to write the sentence. So this is the question, why soft iron cores are laminated? This soft, very important point this is. Soft iron cores are laminated to reduce the, or to minimize the, to reduce or to minimize the eddy current losses, eddy current losses. So the soft iron cores are laminated to minimize the eddy current losses. Clear, Amma? Can I clear? Hope I can clear. No. Working and theory. The value of EMF, the value of EMF induced in the secondary coil, induced in the secondary coil induced in the secondary coil due to alternating voltage. Due to alternating voltage. Due to alternating voltage applied to primary coil. Applied to the primary coil. Primary coil depends upon the number of turns. The number of turns. The number of turns in the secondary coil. In the secondary coil. Number of turns in the secondary coil. We consider an ideal transformer in which the primary has negligible resistance. Primary has negligible resistance and all the flux in the core and all the flux in the core links both primary and secondary windings. Secondary windings. What does this mean? See, always remember an alternating current produces magnetic field. Rate of change of magnetic field is the EMF, that is what is electromagnetic induction. So the value of EMF induced in the secondary coil due to alternating voltage applied in the primary coil. What happens when you apply some voltage in the primary coil, that to an AC, it will create a magnetic field. That magnetic field will be changing because you are applying alternating current and alternating voltage. So the reason the magnetic field varies. The magnetic field is varying means the magnetic flux will also vary. If the magnetic flux is also varying, that is rate of change of magnetic flux, that is the induced EMF. That induced EMF happens in the secondary coil. Okay, because of the primary coil magnetic field, rate of change in magnetic field, that will induce in the secondary coil. So we consider an ideal transformer in which primary has negligible resistance. Primary coil is having no resistance, like that we will consider ideal situation, and all the flux in the core links with the primary and secondary windings. So nothing is wasted. That is the assumption with which we are going ahead. Hope I am clear with this. You can make a note. Can I clear this one? Can I clear? Everyone? Noted? Hope I can clear. Let phi be the flux. What is the flux? Magnetic flux. Okay. In each turn, in each turn, in the core at time t, in the core at time t, in the core at time t, due to current, due to current, due to current, in the primary, in the primary, let the voltage in primary, in primary is equal to Vp. Voltage in the primary is equal to Vp. Let's assume this voltage is applied on it. Okay, let the voltage in primary is equal to Vp. This is the voltage applied in the primary coil. This is the voltage applied on the primary coil. Can I clear? Now, the EMF, induced EMF, induced EMF in the secondary coil, secondary coil, the induced EMF in the secondary coil, ES is equal to negative of Ns into d phi by dt. What is Ns? Ns is number of turns in the secondary coil. Number of turns in the secondary coil. Secondary coil. There is a back EMF also is induced on primary coil. Back EMF is induced in primary coil. Induced in primary coil. Primary coil. What is this back EMF? Back EMF means there will be a magnetic field which will be produced because of some voltage applied in the coil, right? on the primary coil. So what happens there is this magnetic field in turn can create the EMF within that coil itself. Suppose what I'm saying is, this is your coil. You apply an EMF here. This is like an inductor. What, like it is inductor only. If you consider an inductor, what happens with the inductor is that when you supply the voltage or whatever you call current through the inductor, that to an alternating current, it will create a magnetic field. Okay, this magnetic field is not a uniform magnetic field, it is a time varying magnetic field. So the flux will also vary, thereby the rate of change of magnetic flux can create induced EMF. So the induced EMF can happen within this coil. If there is another coil which is surrounding this magnetic field, that is also getting influenced by this magnetic field. This is what happens in the transformer. So this is what it is. Okay, hope I'm clear what is happening. Written, everyone? Written this? Okay. For an ideal transformer, ES is equal to VS and EP is equal to VP. So this is what happens. And now you know that VS, how the voltage is connected to the secondary transformer, it is minus NS into d phi by dt. And now similarly, Vp is equal to minus Np into d phi by dt. Now divide this equation 1 and 2. Divide 1 and 2. Vs by Vp is equal to negative Ns into d phi by dt divided by minus Np into d phi by dt. So d phi by dt is cancelled out. So Vs by Vp is equal to Ns by Np. This much you have to derive a minimum. This relation have to be obtained for an ideal transformer. Please understand this. We are getting a timeout. We'll come back once again. Okay, once noted, please let me know. We'll come back once again. Can I clear? Hello. 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 Hopefully you would have done. So please come back once again, all of you.